If I'm using these for application or problem solving, the first thing is I'm going to make a sketch of the graph given my details. Obviously, when you're sketching the graph, it should look like some form of a quadratic. The second thing, I'm going to identify as many of the properties as possible. What is a vertex, the axis of symmetry, the intercepts, the minimum or maximum value, all the things that are relevant towards my problem. I'm going to create an equation in vertex form to represent what the graph looks like. And I'm going to, and here's a really important one, identify the domain and range restrictions in context to the problem, which means that it might not be XER or YER, maybe it only works in whole numbers, maybe they can't be negative, whatever it is that fits the limitations of my problem. So here's where the domain and range are not as simple as they were before. So let's take a look at the first problem. A 12-meter long suspension bridge is made with rope and logs. The rope forms a parabola with its lowest point 2 meters above the center of the bridge. The rope is attached 6.5 meters above the bridge. So, first we're going to start by drawing out the information we have. We're going to say that it's attached to the one side at 6.5 meters. It is 12 meters long. And it's going to have a lowest point that is 2 meters above the center of the bridge. It's going to look like a parabolic arch. And from here, I can pull out some information. Well, if the entire bridge is 12 meters and the halfway point hits the lowest point, I can also state that I have a vertex that's going to exist halfway along the bridge, or 6 meters in, at a height of 2. I can also state that I started the bridge 0 meters in at a height of 6.5. So what do I know? The direction of the opening is going to be upward. The vertex is at the point of 6 and 2. The equation for the axis of symmetry, drawing that imaginary vertical line, is going to be where x is equal to 6, or the x value at the vertex. Because it opens upward, it's going to have a minimum value of the q value, or 2. For the x and the y-intercept, well, the y-intercept is where we started. That's going to be at 6.5. And there's going to be no x-intercepts, because it's never going to come low enough to ever actually hit the point for an x-intercept to exist. If I'm writing a quadratic equation in the form of y is equal to a bracket x minus p squared plus q to model the situation, I'm going to do the same thing we did in the last lesson. I'm going to state that my y-intercept is where I can pull the x and y from, and my vertex is going to be my p and q, and then I'm just solving for a. So I can say that 6.5 is equal to a bracket 0 for x minus 6 squared plus 2. When I subtract 2 from both sides, I'm going to get 4.5 is equal to negative 6 squared is going to be 36a. Or a is going to equal 4.5 over 36, which is actually the same as 1 over 8. My equation is going to be y is equal to 1 over 8 bracket x minus 6 squared plus 2. What is the domain and range in the context of this problem? Well, I'm going from the beginning of the bridge to the end of the bridge. So I'm going to say that the domain, which is still represented by x, is going to have a lowest point where it's going to be 0. Zero distance has been traveled when the bridge starts, is less than or equal to x, is less than or equal to, at the end of the bridge, because the bridge is 12 meters long, 12. Where in this case, because it can be partial distances, x, e, r. It doesn't have to be whole numbers, it can be anywhere along the bridge. The range is going to be represented by y, where the lowest point that y hits is going to be 2, is less than or equal to y, is less than or equal to, the highest point that it connects is 6.5 meters up, where y, e, r. If I think of how would the quadratic function be different if the lowest point of the bridge were considered the origin of the graph, which means that it's going to be 2 meters above the ground right at when 0 distance is traveled. Well, the bridge itself would still be symmetrical at 12 meters. I would just wind up having a few new points of either 6 and 6.5 or negative 6 and 6.5 to get up to where the top of it is, which means that the equation is going to be the same. All I did was just shift everything to the left by 6, or the graph would have a p-value of 0. This suddenly means that it's going to change the domain and the range, or sorry, not the range, but it's going to change the domain to, instead of being from 0 to 12, it's going to be negative 6 to positive 6, and there can be a negative domain. All right, for the next example, at a Canada Day celebration, a firework is projected vertically into the air and reaches a maximum height of 100 meters. The path of the firework is a parabolic arch, and it lands 30 meters from the launch site. Write an equation that models the height of the firework as a function of the horizontal distance traveled. Well, when I think of how this is going to launch, I'm going to say the firework is going to start at my point of origin. It says that it is going to go up in a parabolic arch, and it is going to land 30 meters from the launch site at a distance of 30 and a height of 0. It's going to hit a maximum height of 100 meters, and that's going to occur at the vertex halfway between where it started and where it ended at a distance of 15. I can say that this is going to be my height. In terms of meters. and this is going to be my distance in terms of meters. So I can pick either of these points to use when solving this. Because it goes to the origin is a good place to use. So I'm going to have an x and y of 0 and 0 is equal to a bracket, my p and my q are in here, x minus 15 squared plus 100. Which means that negative 100, the x is going to be 0 as well. Negative 100 is going to equal negative 15 squared is 225a. Which means that a is going to equal negative 100 over 225. I can divide both these by 25 and get negative 4 over 9. So my equation for this is going to be y is equal to a, which is negative 4 over 9, bracket x minus p, which is 15, squared, plus q, which is 100. At what distance from the launch site is the maximum height reached? It's halfway between where it started and where it landed. It's going to be at 15 meters. What is the domain and the range? Well, the domain is going to be, we didn't give a different variable, so we're going to call it x, where the lowest to the left is going to be 0, is less than or equal to x, which is less than or equal to the furthest it reaches is 30. Where XER. The range is going to be represented by Y, where 0 is the lowest, and it goes up to a maximum of 100, where YER.